Hey everyone, welcome back. I'm Lakshay, developer advocate at DataHub, and I will be your host for today. Uh, so great to see you all here for the May DataHub Town Hall, and we have got some really cool stories lined up. Teams from iFood, Grab, dltHub coming in to share what they have been building upon, plus some big news from the DataHub side that we'll be sharing a bit. Lots of packed in the next hour. So, but before all of that, Alisa, want to start us with our community updates.
Yeah, thanks, Lakshay. Hi, everyone. I'm the community manager here at DataHub. So we can go in some community updates. So on the next slide, 2 weeks ago, actually a week ago on May 1st, 21st, we co-hosted a meetup in Silicon Valley with dltHub and LanceDB. It's called the Missing Data Layer for ML. So we had a great mix of founders, practitioners, and ML builders in the room. And we also made pretty interesting product announcements. So stay tuned on what's coming on our website. Um, and on what's coming up to the next slide. So first, today in a couple of hours, we're having our Toronto meetup happening this afternoon, hosted by our customer Geotab. Um, the data leaders across the Toronto community will be there for live demos, real use cases. So if you happen to be in Toronto and you haven't registered yet, there's a Luma link on the slide. And then on the summits, we're very excited about the two June summits. So our June is anchored by Snowflake Summit in San Francisco, which is happening on June 1st to June 4th. And we are at booth 1309. So please find us there and book a meeting through the link we included in the slide. And then 2 weeks after, on June 15th to 18th, we'll be in the same location again for Databricks Summit at booth 622. And also, please find us, chat with us, and book a meeting with us in the link attached. And we'll be also sending the links in our community Slack very soon. So next up, I also want to touch briefly on the surveys. So we actually ran a community survey when we hit 15,000 in community members. I'd love to share the results with you in this place. So we wanted to say thank you for participating. This is a real signal of how much you care about the community, and it gave us a much sharper picture of what's working and what isn't. So on the left, we heard what you want more of. The number one ask was real world setup walkthroughs. So 76% of you actually said you want to say essentially find tutorials and sharings of how my team uses DataHub as your top content ask. And related to that, you also wanted more peer-led sessions, not just us talking to you. You actually want to learn among yourselves. And on the right is what's getting in the way. So docs were actually the number one theme, saying that about the way finding docs is actually pretty difficult. So, and the next feedback you gave us is having no time in the channel, and also having too many channels. We think we have very friendly room. It's just hard to find your way around our Slack community. So that actually leads us to what we're doing about the survey results on the next slide. So we are coming up with 4 commitments, each one tied directly to something you told us. The first one is having show and tells featuring community members. So this is what I'm really excited about. We'll have a spot for community members to walk through their real data hub setup. So that's coming, and please stay tuned. If that sounds like something you want to do and demo the community, please come find me on Slack after, so we can also start aligning speakers on this front. Secondly, we wanted a clearer path to human when run LLMs can't help you. So we're piloting a visible talk to a human escalation when it falls short. The third is the Slack map. We'll put together a simple guide for especially new joiners that says here's where to ask what and what purpose each channel serves. And last but not least, we are also doing auditing search and findability of our docs as a response to your survey. So thank you so much again for all of those who filled it out. And this is how our community gets better. So please stay tuned for new updates and also improvements in our community. And with that, I'll hand it over back over to Akshay.
Thanks, Lisa. So Everyone, please do join the Slack. If you have any questions, you can join the town hall channel and ask those there. Moving up to the agenda. So here is what we have got lined up. First is iFood. Alexandre from iFood is going to walk us through their journey from 9,000 plus personal AI agents to consolidated super agents, and with DataHub's analytics agent in the mix. Then a session from Grab's team, George and Aezo, on how DataHub evolved from a metadata store into an agentic context engine. Really cool one to learn from. And after that, we have a big announcement for you all. Uh, Maggie with the connector update, what's new across the connectors and what's coming up. And we will close with the dltHub Always on Agentic Data Engineering in Python with a live demo. Uh, all right, let's kick it off. Alexandre, the floor is yours.
So hi everyone, let me just share my screen here. All right. Let me know if it is not, if you are not seeing my screen. But hi everyone. First of all, super excited to be here, and let's dive into a quick intro. I am Alexandre Miyazaki. I am from Brazil. I am currently based on a city called Porto Alegre, which is in the southern part of Brazil. And talk a bit about my education. I have a computer science degree in at the Federal University of Rio Grande do Sul and a big data and data science specialization by the same institute. Talking a bit about my professional journey, I've been developing software for the last 14 years, and my recent experiences were at Globo, which is at the data platform of Globo, which is the biggest Latin America media company. Also at Nubank, not sure if you are aware, but it's one of the biggest digital banks in the world. And also right now I am at the data governance team on iFood. This is actually my second time at iFood. So yeah, and giving a little bit of idea of how big is iFood. So I like to emphasize two numbers in that slide. The first, it is of course our number of orders per month, which is 180 million. I guess that this gives an idea of the size of our technologies operations here. And the second one is the number of employees, which is over 8,000. Around 2,000 are interact with the data infrastructure daily. So this is like the size of the challenge specifically about data governance. And talk a bit about the recent AI journey on iFood. AI is being at the core of our platforms for a long time, but talking specifically about LLMs, on April 2025, the company set a target of every employee having one agent. So they set a target of having more than 8,000 agents created by the end of that year. We hit that target, so we are in this state right now where we have a lot of agents around the company. On March 2026, the data governance team here finished the deployment of the DataHub. So DataHub inside iFood is something quite new. And on April 2026, the company set a shift towards not having a lot of agents. We consider that AI has been successfully adopted on the company. But we want to solve common problems and important problems in an efficient and assertive way. So the company has set some problems that have dedicated teams to solve using LLMs and AI. And right now we are at the tooling phase where those teams are exploring lots of tools and testing a lot of things. So we are here right now. And what does this have to do with the analytics agent? Well, one of the problems that the company sets to solve is the analytics problem. Like they want to make natural language questions to an agent, and they want for that agent to answer based on iFood's data. So this is like the analytics agent here fits like a glove, right? But we were super excited when it was firstly announced on the past town hall. But we had a configuration issue. The iFood uses all the LLM models, not all, but most part, deployed internally. So we were not able to configure our internal LLM platform as a reasoning platform for the analytics agent. So I suggested and implemented the feature to allow these custom LLM endpoints to be configured as reasoning part of the analytics agent. Huge shout out to Srishanka and the DataHub team. It was a very nice experience contributing software to the open source. And it is something that I definitely encourage everyone to do. And the initial tests validated the whole environment. We were able to connect there and to use our LLM platform. And for the next steps, we went to scale this analytics, this usage to a few hundred people and see how things goes from there. We do have some challenges about the project overall, not about using the analytics agent, which is DataHub is, as I have mentioned, at the early stages here at iFood. So we do need a lot of metadata to still be ingested in the tool. And we have some problems because our metadata is a little bit messy. So we are working into be very intentional with how we model that metadata inside the platform. There are some senior leadership pushing for some tool adoptions because, well, conversations about using this or that tool and contracts being made. So this is not like a technology problem. And we are suffering a bit about with the governance issues. Like we want to ensure that the agents are accessing data that has a minimal set of attributes, such as data classification and who's the owner of that data. And also a minimal set of quality, because we don't want agents to be leading decisions with over bad data, right? And we also are with a problem that we already know how to signalize that a table can be used by an agent, but we also want for that table to be only used for people who have access to that data. So this is a little bit of where we are right now. And yeah, that's it. Thanks, everyone.
Thanks, Alexandre. Next up, a session from Grab's team, George and Aezo on how DataHub evolved from a metadata store into an agentic context engine. This one is a playback, but Grab team will be active in Slack, so drop your questions in /town hall channel. Link is in the chat. They will jump in there to answer those. So here is George and Aezo.
All right, hello. My name is George Hurley, and I'm joined today by Aezo. I'm a product manager in the data engineering platforms team here at Grab, and Aezo is a software engineer in our team. So today we're going to be talking to you about how we have used our version of DataHub called Hubble, and its role in powering agents at Grab, as we've kind of transformed it over the last 6 months or so into more of a data context management platform. So yeah, that's what we'll be diving into today. Just before we dive into that too far, data and AI has been an integral part of Grab as a whole, even before the LLM era. Every time you book rides, every time drivers are allocated, that's all been AI in action. So it's been something we've been heavily embedded into our business for a long time, but obviously that's changed a lot over the last few months, as it has everywhere in industry. So recently at our product launch event in GrabX in Jakarta, we unveiled 13 AI-powered experiences, AI assistant, local life, personalized travel experience, much more. There's some articles online to kind of give you a bit more of a sense about the kind of products and agents that we're building, but that's not what we're here to talk to you about today. While the agents get all the glory at those kind of presentations, there is a huge amount of platform and tooling that enables a lot of those agents. So I think you'll be able to see where we're heading with this, but that's what we want to talk to you about today. Before we dive into that, again, just the scale of what we have at Grab. So they're available to everyone, but we have a large amount of data and information. So at the moment, we're about 117 petabytes in the data lake, a daily increment of 300 terabytes, 240,000 tables. The size of it is absolutely enormous. So this is a bit of just a high-level kind of overview of our stack that we have at Grab. The one highlighted in green is Hubble, or our version of DataHub. But effectively, all of these different components and bits and pieces fit together to enable those agents that we mentioned to you at the start. So that's what we want to dive into today, how we used Hubble and how we've kind of changed that over the last few months to enable and be much more agent focused. So Hubble today, we have catalogued about 20,000 different assets. We'll get more into that a bit later, but this includes tables, metrics, attributes, ML models, features, dashboards, all of that. And then recently, context documents as well. It's gone through a pretty big transition in the last 6 to 12 months. We first released an MCP version for Hubble in about August last year. So naturally at that time, all of our usage for Hubble was through the UI, but we've seen a pretty dramatic shift. We now have, as it says over on the right there, about 30% more users using Hubble through the MCP and through their agentic setup than we do through the UI, which, given that we haven't even had this MCP for 12 months, I think is a pretty quick and dramatic shift. So what we're going to talk through is basically the three kind of steps that we've had in kind of what powers that, and how we've kind of gone from a very UI-based tool to now one that is much more focused on serving agents and agentic use cases. All right, so the three steps that we have, we won't spend as long on kind of the first two. We'll try and focus as much as we can today on the third one, but obviously the first step that we had to take in this, even before the LLM kind of era, was around cataloging our data signals. We then went through a certification process to certify our important data signals, a lot around the kind of governance and management of that. We'll share a little bit more on this, but there's also some tech blogs that we can share with you as well. But then the part that we've been doing really in the last little while is how do we evolve our DataHub/Hubble to being a data catalog into a context store that powers our agents. Okay, at this point, I'm going to hand over to Aezo, who's going to walk you through in a bit more detail about these first couple of steps.
we talked about certifications previously, like mentioned by George, and you can read more on our tab blog in Grab. So there's a post 1 and post 2 right below, and yeah, you can find the links provided from the DataHub Town Hall. Next, how we certify data and what we think about the certifications. Of course, this is backed by and powered by DataHub Actions. And as you can see from the diagrams, we go through different criterions. And in certifications, there's a list of criterions that you have to meet. And before it is certified plus and or revoked. And in fact, just like normal certification. And you can see that we actually traverse the lineage and of upstream to find out should it be a certified plus or not. Okay. So next, what do the user see? The user actually see a list of checklists that they want to do to make it certified on Hubble, and you can go through one by one, and at the end of it, you will be certified. So this is more on like certifying and the importance data signals and how it evolves into a context store.
Okay, just to give a bit of background about what we'd seen happening. Context was everywhere, so all of our different users were kind of creating their own context and using that with the Hubble MCP to then generate answers. The challenge with this was it's really hard to scale in terms of how does someone who doesn't know the person who's created the context file work out what they should be able to use, where they should be able to use it. And then also we saw a really wide variety in terms of knowing what you could trust and what you couldn't. Some areas and teams were doing this really well and had very well documented, well understood context. Others really didn't. So through this approach of kind of local teams doing their own thing, it was really hard to understand what context was quality, what context wasn't, and then even also how you assess the quality of that context as well. So we'll touch on that a little bit more later around some of the eval solution we had, but that was kind of the state of where we were. So our first step within that was basically to define a bit of a mental model for what should live where. So we've got kind of data context, skills, and data entity metadata was kind of the three constructs that we defined. The data context is very much the document store that goes into Hubble. So these are the free form, mostly like markdown files that give instructions about how to do analysis. Skills, we currently manage in a separate solution that is grab-wide, where basically you get access to all of the skills that people have written for performing different types of analysis. And then importantly, we also found that a lot of what we needed to do was around updating the data entity metadata itself. So this is all the things that we had through the certification process around table, metric, attribute documentation, lineage, column descriptions, a lot of those things. So the reason we defined this mental model was basically to give a view to our users of where should I go with these things? If I'm talking about a specific table and only referencing that table, that should go to data entity metadata. If I'm talking about a different part of the business and how multiple tables, metrics, and different things live together, that's when it goes into data context. And then if I'm looking at kind of generalized ability of say, how do I do this type of analysis? That's how it then presents into skills. So at the point of consumption of the agent, you're obviously consuming all three of these, but this at least gave a bit of a mental model for where the different components should live and then how agents can get access to those different components as well. The next challenge we then had was that because these teams had very different approaches to how they had managed their context previously, we needed to provide a few different ways that they could get that context into Hubble. So these kind of talk through the three options. The GitLab sync one we'll show a little bit later on, but basically takes documents and specific documents with structures and different things from GitLab, syncs them back to Hubble. Obviously through the UI, you can kind of copy and paste things in there. Honestly, this is the UI option is by far the least adopted option. We see very few people actually creating or editing or updating documents through the UI. And then the other one that we did, which has also been quite popular alongside the GitLab sync, is basically the ability to write back through the MCP. So from a ways of working point of view, users would be creating these context docs to do their own analysis or to do whatever job that they had running. They would be using the Hubble MCP to do that, to get existing access to data or whatever they need. So by providing a right tool within that same MCP, we were able to really minimize the barrier for them to onboard new context docs. So they could just say, yes, this one's good, write it into this place, and it would appear there for anyone else to use across the organization. So the key point in building this context store is we really wanted to make sure that we lowered the barrier as much as possible to how people could onboard context docs. If there was a high barrier to onboarding, then we knew that we were never going to reach the scale where all teams would have context and it would be complete. Okay, I'll pass over to Aezo to talk through the powered by search.
Okay, and it's powered by search. So leveraging DataHub 1.4.0, we managed to evolve from keyword matching to intelligent semantic search. And what do we mean by this is that you can just put natural language and then you can we get converted to embeddings. I will explain more later on the diagram. And this helped to empower this search by ingesting all the embeddings across the three areas, which is datasets, metrics, and context docs, which is the DataHub documentations. So this is an overview. This is pretty similar to the current DataHub practice. On the left, we can have all the sources, and you will get fetched via the GraphQL, partitions, and generate the embeddings, and emit the MCP with the semantic content MCP, right? And they will get pushed to GMS, and GMS will do the necessary storage on the storage layer and the OpenSearch layer, right? And on the search query path, you can see that the entry point are essentially just semantic search GraphQL, and the GMS will convert them into embeddings and then hit the OpenSearch for the results and return the results to the users. So on top of this, we want users to know that the search can be trusted, and how we validate this performance is to have a very curated golden data sets to measure against these three key metrics, mainly the MRR, recall at 20, and also the latency, which is P95. The reason why we have latencies, you might wonder, is because we want the agents to reply promptly as fast as possible for their business questions. Okay, so now we'll demonstrate how we bring our context doc to Hubble, which is our DataHub in this case, and via GitLab, right? You can see we create the GitLab documents, and then we go through the CI pipeline to sync to Hubble in this case, and the document will get created on Hubble. When we see on DataHub, which is Hubble, and you can see the document is there in a read-only format because we only want one source of truth, and you can see that it's there, and you will get converted to embeddings and through the ingestion framework. Yep, and you can do discovery using the cursor. Over here, I'm like just writing some questions about this context doc. And you can see cursor agent managed to find and use the Hubble MCP, right, and returning the portion whereby related to my question. Yep, and I will say thank you to the agent. Yeah, and that's it for this one. So enhancing search. Our next milestone on top of what have been demonstrated by the OSS DataHub, we want to go further by adding relevant scores to allow clients to set thresholds and filter out low confidence results. We don't want to limit their use cases as well. And we also want to return the matching chunk or text, mainly for the re-ranking. So whenever you hit a particular chunk in the semantic search, it will return you the best fit chunks, and then we want to return the corresponding text for them to do re-ranking for even better, higher accuracy, or just more context for the agents, and also to prevent context bloat.
Thanks for that, Aezo. So I just wanted to touch briefly and kind of tie it back to the start. This has resulted in over 3,000, and even in the last week or two since we wrote these slides, I think it's over 3,500 context files now available within Hubble. To go alongside this, we have a skills governance framework that looks at what makes high quality skills and how they combine with our context files. And then the other part that we probably haven't dived into too much detail today, but is a bit of a separate but highly related topic, is then an evals framework for each business vertical. So each business vertical has a set of evals that they are accountable for in terms of maintaining accuracy of both their context file and then any agent that sits on top of that as well. So that's kind of the combination of where we got to. The next part, are there any learnings? Absolutely. We've learned a lot as we've gone through this journey, but one I kind of wanted to touch on and spend a bit of time today is just kind of talking through a bit of our mental model around agents and MCPs. Now, I know MCPs kind of, people are also going down a bit of an API-based approach, and we are exploring that as well, but I think generally what I see when we read a lot around what's happening in industry, people are talking about the agents that they've built sitting on top. As a centralized platform team, we've kind of done a bit of work building agents, but also invested a lot of time, as you've seen, in building the MCP that sits on top of Hubble. And the analogy that I think makes a lot of sense here is that agents provide you something that you can kind of, like going and getting a bike. You can easily jump on, you can get where you need to go, and it does what it does. But where we've seen kind of the most innovative and the most exciting solutions has really been when we've exposed our raw MCP tools and capabilities to users, much kind of like on the right-hand side of this analogy, where they might then create a bike, they might create a different type of bike, they might create a scooter, who knows what will be created. That's really where we've seen a lot more of the exciting kind of AI use cases, which if we go back to all the way when we mentioned at the start, those use cases that we were talking about at the GrabX launch event last month, a lot of them will leverage the MCPs like Hubble to then build on top of those capabilities. So I think from a platform point of view, we've seen really exciting stuff by providing high quality tooling, as well as other use cases which fit into agents, but also really focusing on the tools. Great. I think that's all we've got for you. Thank you very much for having us.
Awesome. That was such a great session by the Grab team. It's always exciting to see where teams are pushing DataHub, whether as a metadata platform or more recently as a context platform. Super interesting to hear what they're doing with the context docs feature. I completely relate to a lot of the interesting use cases that they've done. We're seeing that play out live in so many open source community adopters of DataHub, as well as our customers. And I just wanted to drop in and say hi and announce something quick. It's been a really interesting day for us. If you've been paying attention to the news, or maybe you haven't because you're at Town Hall and you're busy watching everything that we are sharing. But we had a pretty big announcement that went out today. DataHub Cloud is announcing the context platform launch as part of our move towards becoming a context layer that AI agents can actually use to drive real outcomes, whether it is talking to data and in the future doing more interesting things with it. VentureBeat ran a nice article about us. They went deep into a particular aspect of the context platform, how we are mining query logs as well as all of your rich metadata from your BI layer to build the context, build essentially the semantic layer that AI agents need to stop hallucinating and get great answers from your talk to data use cases. It was really cool to hear Alex earlier today talk about how the analytics agent is already starting to drive outcomes for iFood. It's really cool to see something that we just announced last month start to get used in companies already. It is amazing to see how fast the industry is moving these days. We have a launch page that you can kind of take a picture of, QR code, and that'll give you a lot of details about what we are launching today. As you're part of the community, you've probably seen this already. DataHub is evolving to becoming a context platform for AI agents, but today is the day where we put it all together and put it in our cloud product. So take a look at all of the materials. Quick deep dive, and we'll do a deeper session in a future town hall. Step one, context intelligence. If you watched the Pinterest talk, you'll know what I'm talking about. That's one of the approaches that we've applied into this layer. But there's, of course, a lot more that's going on under the hood. The context intelligence layer essentially dips into all of the query logs, the semantic models, and all of the usage and popularity signals that we get from your warehouse, your BI tools, your upstream systems, and all of the information that you've already provided DataHub. And we use that to turn them into the DataHub semantic layer. The semantic layer right now is represented in terms of context documents. Semantic anchors is what we call them. It's a very specific kind of format that we've come up with as we've worked with a bunch of design partners to hone in on what is the right capability, what is the right set of information that really makes agents perform really well. And so, as you might be wondering, there are, of course, connectivity and interoperability pieces with the Snowflake semantic layer and the Databricks semantic layer and all of the other semantic layers. And stay tuned for updates on where context intelligence is going and the kind of semantic anchors that we are able to generate. The next piece, once you generate kind of that bootstrap semantic layer, is being able to actually get your data experts to come in and review, approve, and enrich that context. And that's where Context Hub comes in. So this second stage of context: first extract, refine, and produce that bootstrap semantic layer. And then the second step is having data experts come in and approve or reject or actually test the impact of those changes on your text to SQL results. So we're launching not just an intelligence layer, but also an approval and review layer, which includes evals for you to actually evaluate the impact of those changes. These evals run on the platform. So essentially DataHub Cloud can actually run evals on your behalf and prove to your expert whether these changes are safe to make or not. And then, of course, finally, your business user, who's probably not exactly in DataHub all the time. You heard from the Grab team, a lot of the usage of systems like DataHub will happen outside of the product. Most of the use cases will be in agents. Perhaps there's a talk to data agent that someone is using out on the field. DataHub is able to now intercept those calls and provide disambiguation questions, provide acquisition questions around context to help keep the context graph continuously updated and refined. And that really means that people don't have to remember to come to DataHub to update anything. They can just keep asking questions wherever they are, and the context layer and the context graph continues to improve and get better. So that's it. And if you like architecture pictures, this is really where we are building. This is the picture that we are building towards. On the lower half, all your unstructured and structured data sources, your business apps, and all of your semantic knowledge getting pulled in to our context store, which has expanded significantly beyond just technical metadata. It now includes embeddings. It includes a knowledge layer. It also includes memory. And then on top of that lives essentially the context layer. And this includes the context intelligence capabilities that we're announcing today, the ability to automatically infer your semantic layer and your context layer. The Context Hub capabilities, this is where your experts can come in, refine, approve, agree on what good looks like, along with evaluations that are able to prove that your context is actually changing in the right way, and then exposing all of that through agent-friendly interfaces. MCP, we've got our Agent Context Kit, which provides targeted APIs for individual frameworks. And then, of course, we have skills that wrap a lot of this up. And then guess what? Humans continue to be super important. So we have and continue to invest in the user experience for humans via Ask DataHub as well as via other DataHub native interfaces. So that's all, folks. And most importantly, a lot of this work that has happened could not have happened without the amazing engagement from our design partners in building this. Miro is one of our customers who's gone live with us today. They have been able to nearly double their accuracy of their Snowflake Cortex from close to 50% to around 90%. When they started out, Snowflake Cortex did not have the semantic context that they needed. And just by Snowflake metadata, they couldn't bridge that gap. with DataHub, they were able to bring a lot of that context together. And now their analyst agent is now doing a lot better and is a lot more trustworthy. And that's obviously leading to a lot more adoption. And within the open source community, you heard a similar story with Pinterest. We're excited to have been able to drive the same outcomes or even better outcomes for Miro. And we're, as people say, we're just getting started. Super excited. But if you really want to see what this looks like in person, we are actually at Snowflake Summit right around the corner, San Francisco, June 1st to 4th. Here's the QR code. Scan it. We are going to be busy, but you should still find slots to book time with the team. And we would love to show you what this product looks like in person. That's the booth number. And I am excited to have Maggie join us. She has been a big part of building a lot of the features that we're launching. So it's been a busy last few weeks for us, but we're so excited and happy. So welcome, Maggie, and tell us what the open source community has been building with DataHub.
You bet. All right, I'm going to take over. Hello, everybody. If we haven't met, I'm Maggie. I'm part of the founding team over at DataHub. And I'm going to give a very quick update on what we've been up to on kind of the connector front. So guess what is required for any context agent to do anything effectively? It's metadata. So the more, one of our continued focuses is making sure that we are continuing to expand both the breadth of types of metadata that we're ingesting in a DataHub and also the depth or kind of the quality of that metadata, the performance of that metadata. So I just wanted to give a quick kind of overview of what has been happening in the open source project over the past couple of months. So I think this might actually be a record for us in terms of throughput. Did I validate that? No, but my intuition tells me I'm right. But we actually shipped a ton of brand new connectors just over the past couple of months, and a ton are currently in flight and about to kind of merge in. So specifically, we have Airbyte, Matillion, dltHub, and Informatica, which is kind of expanding our footprint on the kind of workflow or data pipeline orchestration, ETL pipeline kind of component of your data stack. We also just recently, I think within the past maybe week, merged a connector for ThoughtSpot. So folks that are using ThoughtSpot for your kind of BI layer or your kind of text to insight layer, we have a native connector for that. We also received, I believe it was a community contribution for Timescale, which is a time series Postgres database. So all of those are live and ready to go. We also currently in flight are the core DataHub team is actively, excuse me, working on a new connector for Monte Carlo. So for those of you who are using Monte Carlo, you've gone through the effort to kind of perfectly orchestrate all of your observability across your data stack. What you'll be able to do is ingest all of those data quality signals into DataHub. That's fantastic context, speaking of which, for your agents to kind of determine which data assets are well tested, well covered, reliable, etc. You'll also be able to kind of auto resolve incidents in DataHub as well. So a comparable kind of, or a comparison here is kind of how we handle DBT tests. So we're just kind of, shooting for a similar experience there. We're also deepening our footprint, our investment in our footprint with SAP, specifically looking into DataSphere. We kicked that off just this week. And then we have active development happening with AWS QuickSight. So again, on kind of the BI layer, kind of at the far or the right side of the lineage graph. And then Tomasz on the core team has a PR open, and we're going through some kind of testing for AWS Firehose and Kinesis. So we also have our, we're investing more in kind of the streaming end of things. So like I said, this is there's a lot moving in here in terms of like new connectors that we're pulling in. But we're also always continuing to invest in the connectors that we already have. So over the past, and this is just kind of a summary because it's been a while since I've talked to you guys, summary of what we've seen or shipped over the past 2 months. I'm going to group this into 4 different sections, but keep in mind this is covering over 250, I think 272 or something PRs. So this is a gross oversimplification of the work that has been done over the past 2 months. So we will kick things off with letting folks know that we have removed Great Expectations as a dependency. This probably, you may not know that this was a thing, but this has been a kind of pain point for folks in the community who were looking to upgrade their Great Expectations environment, but we had a pinned version of it that was many years old. So we have removed that as a hard dependency. We've replaced our SQL profiling to now use SQL Alchemy instead of Great Expectations. So if you were blocked by that before, you are no longer blocked. That being said, if you want to retain that same behavior, you absolutely can. We have a path forward for you in our version 1.6.0 updating DataHub guide. So in the theme of context or kind of agentic workflows, we are expanding our support, our investment in our support for semantic layers native in kind of external sources. So to date, or prior to the last couple of months, we had support for ingesting dbt semantic models and Snowflake semantic views. We have expanded that out to support for Unity catalog metric views and Sigma data models. So those are going to be really powerful and very useful, strong signals for agents to kind of collect and kind of have those canonical definitions of how things all work together. So if your team is going through those workflows, we're automatically going to be pulling those in during ingestion. Speaking of automatically, we are always investing in improving our coverage of automatic lineage detection. It is the backbone of DataHub's knowledge graph. And so as the kind of set of external sources, as those feature sets expand, we need to make sure that our lineage graph is keeping up with that. So specifically, we have for Snowflake, for folks that are using dynamic tables, we are now pulling in lineage. One minor note, and again, this is kind of like in the weeds a little bit, but for folks that are using Snowflake dynamic tables but don't have access to the DDL, we got you covered. So that's no longer going to be a limitation there. In terms of Sigma, we have improved our comprehensive lineage back to the source warehouse. So you can think of that as a way to kind of say, for a Sigma, I believe it's workbooks or kind of the presentation or BI layer, what are the underlying data assets in Snowflake that are Snowflake or Redshift or BigQuery or whatever your warehouse is that are powering those. So you have kind of the full end-to-end graph. Glue and Iceberg lineage, we have made some big improvements there, including JDBC, upstream lineage on Glue jobs. And then Athena mapping that back to the metastore in either Glue or Iceberg. This is a fix. Before this, Athena was pointing to kind of like the raw S3 paths, not necessarily what folks were looking for. So we made an update there. So if you're running Athena with Glue and or Iceberg, we got you covered there. And then last but certainly not least, Power BI, we have some big improvements to lineage coverage and accuracy by migrating over to Microsoft, I almost said Michael, Microsoft's official mQuery parser. And then there's always the fun part of keeping up with large volumes of metadata ingestion. So again, we're always investing in addressing performance issues or kind of fine-tuning our performance. BigQuery is one for teams that are heavy users of tag-based policies, specifically on columns, that could lead to really long ingestion runtimes in the past. We've resolved that and substantially reduced the runtime on there. SAP HANA, again, this is kind of in the investment in the SAP ecosystem. This is interesting because we've had an SAP HANA connector for at least maybe 2 or 3 years. It's been sitting around for a while, but I think it was pretty bare bones and not really doing the trick. So shout out to the Johnny over on my team, who took the time to kind of overhaul that and make sure that not only is it production ready and performant, but also we have column level lineage, stored procedure lineage, and query usage as well. And then Teradata is one that historically has had for very large instances of Teradata could lead to very long ingestion runtime. We got much smarter about what we're scanning and actually processing. And we've seen that, jobs that are ingestion jobs that used to take hours are now taking a matter of minutes. So lots packed in here. Again, this is only scratching the surface, but wanted to make sure that we gave you all kind of a lens into what's been going on over here. Always excited for feedback, questions. Feel free to send me a message in Slack. And I'm going to hand it over to Elvis. Elvis, are you here? I think you're here. Maybe not. There we go.
Hello.
All right, Elvis, I'll hand it over to you. Take it away.
Cool. Maybe move these slides over to this window. Wait, Maggie, can you see this?
Yes, the most please is that.
All right, cool. Yeah, so hey everyone, my name is Elvis. I work at dltHub. We recently got a connector with DataHub, and so now it's actually really easy to load data from dltHub and Lineage back into DataHub. And so a little bit of background on the library. So we're also an open source project. We are a Python SDK, and we try to make it really easy for people to move data. And so like a good example here is like you might have a MySQL database, and ideally if you want to like load data into like DuckDB or Snowflake or BigQuery, you can just create a DLT pipeline, and then you can run this pipeline to actually move the data into this data warehouse that you have. And a second thing is that because of the new connector with DataHub, it's also very easy for you to register your actual metadata and lineage back into DataHub, which is what you would typically use as like your catalog for context. Yeah, and so one thing I do want to note is that some of these statistics are a bit outdated, and so we were around 6 million monthly Python downloads probably back in like March, and I think now it's around 10 million, and a lot of this is just due to like agents and AI traffic and Cloud and Codex looking towards DLT whenever they need to like build a pipeline or fetch more context for themselves. And then the other thing that I wanted to note as well is that we will also be at Snowflake Summit this year or next week, along with DataHub, and we have a lot of shared customers with Snowflake. Yeah, so essentially the mission is to just make it really easy for data engineers as well as data engineers and their agents to build these data pipelines. And so ideally you can have this like framework that works really, really well for just moving data from any type of source. So be it REST APIs or SQL databases or CSVs, pandas data frames. Ideally you can just pass those in as a source into a pipeline and then arbitrarily choose a destination. Yeah, and so for this particular demo, we're going to be extracting some data from GitHub. And so we're going to pull a bunch of commits from the DataHub repo, and we're going to be using Cloud Code essentially to do all of this. And then the hope here is that with DLT, we can just load it into DuckDB locally. That way we can inspect it, we can validate the data. And then after we actually validate and look at the data and see that it's good, ideally we'll swap out DuckDB for BigQuery, actually deploy this pipeline because we've already tested it locally. And then we will run an ingestion pipeline so that we can actually load some of this metadata back into DataHub, right? And so DataHub gives us a lot of things here. We get like ownerships, we get tags. It makes it really clear like who owns what data. You can also add policies and conventions. And so the hope here is that with both of these tools together, you can have essentially like full visibility into your data platform. And another nice thing is that we both have MCP servers and we both have skills. And so you can also do all of this all from Cloud Code, which is what I think both of our teams believe is like the future of what data engineering will look like. Yeah. So I want to give a quick demo. And so I just want to call out, this is the command that you would use to start working with dltHub. You can just do UVX dltHub -start. And then this will essentially go through our onboarding so that we can actually like get a pipeline up and running. And this is brand new. This launched last week. So I'm going to switch to my terminal. I'm pretty sure people can still see this. And so on the left, I have a notebook that I'll walk through. And then on the right is my terminal page. And so I'm just going to like run these commands in my terminal and then show folks what the experience looks like. So whenever I run this command, I'm going to get essentially a new workspace. And so in this case, I'll just do a DataHub. And then we can choose between, starter and minimal. I would go with starter because it loads more skills. So I do starter. I'm using just Claude, so I can, ignore cursor and codex. And then I can install the workspace. And so once this is done running, I can actually cd into this directory. So in this case, I can cd here. And then if I look at this, I can see that we have a bunch of Python files, right? So we have a starter template for making a pipeline, for running transformations, for like essentially running like data quality expressions against the data that you eventually do load. And then you also have this Claude folder that has a bunch of skills. So I'm actually gonna create I'm gonna just save this, that way I can always I can show people the difference. Yeah. So after I actually have after I do the onboarding, I can actually do DLT AI, and I can do toolkit, and I can do toolkit list. And so this is just a CLI command that makes it easy for me to see the toolkits that are available to me. And so we come with a bunch of different toolkits, and toolkits are essentially just collections of skills. And so like, and we're going to use actually this REST API pipeline one. And so for example, I can click this, then I can install it, and then I can see that it is going to pull down different skills. So I'm actually going to install these other ones. And then if I go into Cloud, for example, and I do skills, I can see that we loaded a bunch of skills for dltHub. And so the hope here is that we can make a toolkit for all of your different data tasks. That way it's just easier for data engineers to do their jobs. And then after I get the DLT skills, I'm actually going to also register my, I'm not sure why this is not working. I'll fix that later. But we can also pull down some skills for DataHub. And then once we have a bunch of skills, we can also install the DataHub MCP. And so the idea is that when we have both sets of skills, we can pretty much just live in Cloud Code. And so if I go back to Cloud Code, typically we'll use this find source skill. So for example, I might say, find my GitHub source, and then Cloud can essentially go out to the web, and then it can actually fetch context on how GitHub works. And so in this particular case, the idea is that we can give, let me close this. The idea is that we can essentially give an agent context on a bunch of different APIs. And then this context, in addition to a very nice SDK, actually makes it really easy for the agent to pretty much one-shot any data pipeline, right? And so I actually already did this. So I'm not going to actually Cloud Code now. I'm just going to switch to the project that I already made. And so to give people an overview of what it looks like, after I'm done working with Claude to actually build a pipeline, this is what the code will look like. And so the way that dltHub works is that we have resources, and resources are essentially just tables that live in a database. So in the case of GitHub, we might have a table for commits, we might have a table for issues or pull requests, etc. And then I can essentially just add this resource decorator. And then this will tell DLT how to actually load this into the warehouse. So for this particular resource, every time we pull it, we're going to append. And we're appending because we actually have a cursor. And so every time we run this, we're just going to run from the last time the cursor ran. And so this initial pipeline is going to load from the beginning of this year. And then I can essentially pull a bunch of these resources into one source. So this GitHub source is going to be the database that lands in your data warehouse. And the cool thing about having this like this like closure pattern is that it makes it really easy for me to like share, for example, one client across, multiple resource calls. And so once I'm done creating my resource, I can pretty much just make a DLT pipeline. And so I do DLT.pipeline. I can change this destination. So this can be Snowflake, this can be BigQuery. And then the hope here is that changing the destination is really just one line of code, plus, for example, some tokens so that we can actually authenticate into this warehouse, right? And so I'm going to leave this as a DuckDB for now. And so, yeah. And so once I actually have a pipeline, I can actually run it. So I'm going to run this pipeline, for example, and it shouldn't load anything because I've already loaded everything from the beginning of the year. Yeah. So we can see it starts off at the cursor that we last ran, and then we're going to load 0 packages because we already did a backfill today. And then once I'm actually done running this pipeline, I can also, for example, run this ingestion pipeline. So I can like register this into DataHub. And so I also already ran this, but yeah. And so once this is done, for example, we can see that, we loaded some events into DataHub. And so now this, lets me see it in my UI, right? And I have a couple of little like probing commands. So I do want to show that. So like actually, let me run a more filtered version of this. So the nice thing here is that we can see that, with our authentication token and with our workspace, I can see that, this is the version of DataHub that we're on and that we're actually loading to cloud, right? So since I've actually loaded some of this into DataHub, we can actually jump back into the browser, and then I can actually go to my DataHub instance. And so we have a bunch of things here. So I can see that we have our BigQuery platform. And so if I go into this, you can see that we actually registered our actual BigQuery catalog. And like if I like jump into one of these, I can see that, I can see the contents. So I can see that, that when DLT runs a pipeline, we essentially will save things like DLT load, DLT pipeline state, DLT version. And the idea is that we can keep all of this metadata into the destination, and that makes it easy for us to, for example, load data from a bunch of like lambdas, and then the lambdas can just like look at the destination to get the state of that particular pipeline. So this helps us support concurrent writes on things like object store, right? Like being able to keep the state data on the destination. Yeah. So yeah, so for this particular demo, we have this GitHub pipeline. I can also see, we have a few assets in here. So we have this commits, we have commit parents, and then we can also see that, we have some documentation for this pipeline. And so this is helpful because, this makes it easy for people to like see the context for the different pipelines, as well as like see like the owner. So I'm the owner for this one. Yeah. Cool. So now that we know loading into DataHub works, the thing that I typically do is I usually will run a Marimo notebook. And so Marimo notebooks are kind of like Jupyter notebooks, but more modern. And so I'm just going to walk through this notebook really quickly. And so my typical data engineering workflow is I will use Cloud Code to build a DLT pipeline. And then when I actually want to see the data and see whether it's good, I'll jump into Marimo. And so, for example, after I run the pipeline, what I can do is I can actually attach to it. And so I can DLT attach, connect to this pipeline, and this now gives me the ability to like introspect on the data from that pipeline run. And so in this case, I'm running, so if I actually look at this, I can see I'm doing pipeline, and then I have this data set entity, and this lets me look at like the tables. This lets me look at the actual data. And so in this case, we have commits parents. I can, for example, pull out the schema from the pipeline, and then I can, return it as mermaid or as JSON. And so we can see that this commits table has, a bunch of columns, mostly data around the committers, like the author. Yeah, and we can also see that how it's connected to these other tables. So I can see we have DLT loads here, and then the DLT load ID, is what we use as a foreign key to track like when this pipeline ran and things. And cool. And so once I actually have this data set, I can, for example, index a table. And so in this case, I'm pulling out the commits table. and then I can essentially return this as a data frame. I can return it as polars or pandas or as arrow, and then I can start actually transforming the data and then like making it easier to use, right? And so in this case, I'm going to create a new column. So I'm going to create a GitHub URL column. And so in this case, the most recent commit is actually, I guess the last three are from Maggie. We also have, Chief, we have the boss. And the cool thing is that since I added this new column, I can actually, for example, jump into this like user if I wanted to. And it's actually, it's cool to see a CEO that, codes still, which is pretty nice. Yeah, and so after I see my data, I might want to run various transformations. And so we use this library called IBIS. And so IBIS is nice because it lets us write Python expressions that get compiled into SQL. And then these will run against your data warehouse, right? And so all of these expressions that the agent might build for you or you might write yourself will get run in SQL. So they're pretty efficient. And so here's an example of what a query might look like. I can, for example, filter, and then I can actually pass in this assertion. I can do a group by, I can do an aggregation on, this particular column, and then I can, I can limit it as well, right? And so we actually have some queries here. And so in this case, I'm doing things like, how many authors are there? How many commits per author? How many commits are verified? And then I also have, the most latest commit. And so this is nice because Cloud Code can build this for me. And the reason Cloud Code can do that is because, this notebook, it's just code. And so Cloud can build a notebook for me. And it makes it really easy for me to now do like analyses. And if you're having trouble building this notebook, the nice thing is that we also have like skills to help people build notebooks like this. And so the next thing I did is I had Claude filter the commit messages, right? And so we just ran this regular expression, and I can, for example, see that like 33% of commits are fixes, 23% are features, 16% are other, and then we have some docs, and then we have these like merging the pull requests. Yeah, and so it's really nice for me to get, data on like my own repo, for example, and the hope is to just make this really, really easy. And then we can also see, for example, top authors. And so David here looks like he's a beast. We have like Sergio and, some other folks. Yeah, and so the hope is that the same way that we have pull requests to get a sense of whether new code is good, ideally, if you're building a data pipeline, you might care less so about the code behind the pipeline, but you might care about, these charts and these graphs and these tables as a way for seeing if the pipeline was actually good, right? Because your pipeline could have great code, but if it's like loading bad data or loading the wrong data, then, it doesn't mean much. Yeah, and then we can also see like, commits per week. Yeah, so it's pretty easy to get started, especially with skills. And so the next thing that I do after this is I kind of just use the MCP server. And so, so I have another tab here. And so I can see that when I look at the MCP servers we have this DataHub MCP, and then I can actually, go into it, then I can view the tools. And so we have like a search tool, we have lineage, we have, dataset queries, entities. And so I actually ran some queries also in this next tab. And so, for example, I asked, what's in our BigQuery catalog? And we can see that, we have a bunch of tables, for example, in this data set. We have, I guess, 226 data sets total. And then I could just, use, Claude to ask more questions about my data, right? And so I find this to be super helpful because I'm someone that doesn't want to leave Claude code. And so I actually did this as well for our GitHub pipeline. And so I, for example, asked, what columns does our pipeline have? And I can see, and this is calling the DataHub MCP. And so I'll get, things back like this is our metadata, top level commits, authors, and authors has, 21 columns. And so this kind of just feels like we are finally realizing this future where people can actually self-serve analytics. And I feel like having the context powered by DataHub is really nice because we can kind of guarantee that the questions that people ask actually get answers that are correct. Yeah. And so I think that's the last thing I wanted to show on the demo site. So I'm going to just jump back into these slides and then I can go back into slideshow. Yeah. And so Our hope is to make it as easy as possible for people to work with data. So, one line command. And ideally, when you're actually done building your pipeline, you can also deploy it really easily. Like you don't have to set up, Kubernetes or, a custom data platform or set up, EKS and Glue and all of these things. Hopefully you can kind of just use like DLT and DataHub and then just like run it on your own compute. But if you don't want to run it on your own compute, we also make it really easy to deploy pipelines. And so a quick example of this. So instead of me, for example, doing like Python and pipeline, I can, for example, do like dltHub run, and then I can also pass in my pipeline here. And this will automatically get deployed into the cloud and then run in the cloud. And instead of us using DuckDB, for example, you would switch out to Snowflake, right? And so the hope is that you don't have to write, a different code path if you're developing locally or developing for your production environment. And ideally, this is just one command. And eventually, you can also give agents the ability to build and run these pipelines. So in addition to an agent writing the code for the pipeline, ideally, you can also deploy the pipeline and then get, like temporary storage that we provision it. And then it can actually inspect the data that's loaded by the pipeline it wrote, and then eventually fix its own pipeline if the data doesn't look good. So that's kind of the future we're trying to work towards. Yeah. And so I think this is really exciting. And I think these types of developer experiences are only possible because a lot of these tools are open source. And so DLT is open source, DataHub, IBIS, Arrow, Marimo, they're all open source. And the mechanism here is that if I want something to exist, or if I want a user experience to exist as it relates to both of our products, I don't actually have to, for example, like submit a ticket to DataHub and then like wait for them to prioritize it and then wait for them to actually do it. I can actually, open up a pull request myself, and then I can do that in partnership with their product team. That way I can do it correctly. I can do it in a way that's helpful to not just us, but also their users. And so being able to have this like symbiotic relationship where people aren't blocked by bureaucracy makes it so that we can have, these product experiences that are actually really nice for the end user. And what I'd say is the tools, the older tools, the legacy tools, because they don't integrate very well, you end up having, for example, a custom data platform just to connect these individual tools. And I think we are finally at the point where we can have actually great developer experiences for data engineers and also just developers in general. Yeah. And so, we also have a Slack. We also have, this is a link to the Pro product. And so the Pro product comes with $30 worth of free credits, which is actually a lot. For example, I think like a 5-tran pipeline that costs around $5,000 is a couple cents in DLT. And so ideally, you probably can do most of your data engineering workloads with like $30 credits. Yeah, so if people want to join our Slack, that'd be really helpful. And I'm also in the DataHub Slack, and so if people have any follow-up questions, you can always just tag me there. But yeah, thanks for letting me demo, and it's been fun being in the tunnel. I'm gonna stop sharing.
Thanks, Elvis.
Yeah.
That was a packed hour. Massive thanks to all the speakers, Alexandre, George, Aezo, and Shishank and Maggie too for the announcements and sharing of the updates. We had 5 different stories, but one shared thread, context to action. So yeah, keep the conversation going in Slack, drop your questions in the download channel, and do check out the analytics agent if you haven't yet. But few quick reminders as well. We will have more onto the context platform in upcoming town halls, so stay tuned. Snowflake Summit is next week, so if you're visiting it up, do come to the booth 1309. And the recording and the blog will be shared shortly in the Slack, so please do join. So yeah, until next month, thank you for showing up, for asking great questions and building cool stuff out there. So cool. See you next time, everyone. Thank you.